Alright, so today we're starting a new chapter, chapter 3. It's a chapter on rational numbers. Rational numbers is a fancy way of saying fractions. So they're interchangeable to some extent. Whenever you see the word fraction, you might want to think about rationals. Or vice versa, when people talk about rationals, a lot of times what they're talking about is fractions. It's not the whole story, but it's roughly speaking the essence of the story. Rationals, same thing as fractions. Now, this is a very, very important chapter. Today, we start to learn everything that you ever want to know about fractions. But we really try to explain it as thoroughly as it could possibly humanly be explained. Alright, so that there's no doubt on how we handle fractions. Specifically, we want to know how to add them, subtract them, multiply them, divide them, everything that has to do with fractions. So, on with it. We're going to start off with a powerful definition of a fraction. Now we do this because you or I or anybody, we have no business adding fractions or subtracting fractions or even talking about fractions if we don't have a proper definition of them. So this is an incredibly important place to start. What do we mean when we say things, for example, 1/3? Well, this type of fraction we've encountered before. We said the definition for 1/3 is the killer of 3, that is the multiplicative killer, or the fancy name for that is the multiplicative inverse. We even had an excellent symbol for it, multiplicative killer. It works the other way around. 1/3 times 3, of course, was born to be the killer of 3, so when you multiply them you get the identity, the multiplicative identity. That right there is multiplicative inverses. The definition of 1/3, it was born to be the multiplicative inverse of 3. Okay, that's what 1/3 means. There's nothing special about 1/3. You see, you could do the same thing if we asked what is 1/5. Well, it was born to be the 5 killer, so 8 times 5 gives you 1 by definition of multiplicative inverses, and on and on and on. Okay, that's the meaning of a fraction that has a 1 on top. What we haven't done yet is, well, what do we mean when we have fractions that don't have a 1 on top? Suppose, for example, they have like 2 or 3 or -7 on top. What then what do we mean? So for that, we consider a different kind of fraction, like 5/3. I know you might have heard before that it's you take a pizza and you cut up into 3 pieces. That's an okay definition for babies. But we want something much, much stronger. So we're going to propose the following. We're going to propose the following meaning for that symbol right there. That's going to mean for us 5 times, hold on, I'll write it like this. 5/3 will mean forever and ever 5 multiplicative inverses of 3. That's the definition of a generic fraction. Okay, this is a definition, accepted definition. When I write that 5/3, when we all write that, we mean 5 multiplicative inverses of 3. Okay, that right there, although seems meaningless, it becomes an incredibly pivotal definition. We will use it over and over and over again. Every time you want to know how to add fractions, you will look to the definition. Every time you want to simplify fractions, you would look to the definition. If you want to learn how to multiply fractions, you would look to the definition. This is huge, huge stuff. That's why it's incredibly important. So you may want to practice that a few times. 8/7, what's the definition? It means 8 times 1/7. That's the definition of A/B. It also works backwards. We have a couple more examples. This, of course, means 3 times 1/7 by definition of A/B. This, of course, means 2 times 1/-5 by definition of A/B. And, of course, this means 3 times 1/13 by definition of A/B. You see, all you do is take this 3 to the side as a coefficient and replace the numerator, that's the thing on top, with a 1. That's the definition of a fraction. It works so well not just on numbers, but on all your future fractions for the rest of your life, no matter if the fractions are polynomials or whatnot. This is such a strong definition, it'll carry you for the remainder of your life. This definition would be good. This will be -4 times the multiplicative inverse of x squared plus 1. I was saying, you could also use it backwards. If you ever see something like this, 7 times a 1 over that, you can think, whoa, this looks like somebody brought it down. Maybe I could use the definition of a fraction and put that back up there. That, of course, is the definition of a fraction used a bit backwards, but nevertheless, it's the same definition. That's the definition of a fraction. Okay? Now let's start to prove some theorems with it, yeah?